Hi, this is Chairman Cho. Today, I'm presenting our ICCV 2023 paper, DALL-Eval, Probing the Reasoning Skills and Social Biases of Text-to-Image Generation Models. We propose two novel evaluation aspects for text-to-image generation models: visual reasoning skills and social biases. Here's an overview of recent progress in text-to-image generation models. Back in the day, until 2021, the models could just generate blurry images from text prompts. So people commonly have used metrics like FID, which measures how images look realistic. Recently, text-to-image generation models have shown remarkable progress in the last few years. Now they can generate very realistic images and scoring very low FID scores on benchmarks. However, there are still challenges even with the recent models. For example, they're not good at generating objects with a specific count. In this image, the model generates 5 cubes instead of 3 cubes. The models also have open biases. With the text prompt nurse, the model always generates the female images. These challenges are not measurable with the existing metrics. We need to better understand what they're good at and what they still suffer from. In this work, we propose two novel evaluation criteria: visual reasoning skills and social biases. Okay, let's look into details of the visual reasoning skills. We define 3 skills: object recognition, object counting, and spatial relation understanding. For this, we first prepare a set of diagnostic prompts for each skill and generate images from them. Then, we run object detection and see if the detection results are aligned with the input prompts. In this example, the model correctly generated a cat and a dog. However, it fails to place the cat to the left side of the dog. While the previous metrics give a high score to this image as it looks real, but our skill evaluation judges in terms of spatial relation and marks this example as incorrect. One advantage of skill-based evaluation is that we can now pinpoint text-to-image models' weaknesses. As shown in the examples, given the prompt, the model A generates less realistic images but shows more correct counting capabilities. In contrast, the model B generates more realistic images but makes mistakes in counting. With the skill-based evaluation, we can have a better understanding of how we should improve our text-to-image models. We introduced PaintSkills, a diagnostic dataset for 3 visual reasoning skills. We collect the dataset in 3 steps. First, we define scene configurations and templates for each skill. Then, we generate text prompts by composing objects, numbers, and spatial relations into templates. Finally, we generate images from the scene configurations using a 3D simulator. While existing multimodal datasets have superior correlations between objects, attributes, and relations, we explicitly control our PaintSkills dataset so that text-to-image models cannot just score high by memorizing data statistics. Here we show our overall skill accuracy evaluation of the 3 public text-to-image generation models. Our automatic metrics show high correlation with human judgments. We see different models are good at different skills. For example, Stable Diffusion is better at object skill, while Mean DALL-E is better at count and spatial skills. When comparing the overall accuracy, we found counting spatial skills are harder than object skill. Our skill-based evaluation can provide even deeper insights by looking into per split and per task accuracy. Please check our paper for more details. We also measure gender and skin tone biases of text-to-image models. For this, we first prepare a set of diagnostic prompts with different professions. Then, we generate images from them and detect gender, skin tone, and attributes from the images. We use BLIP2 model for gender and attribute detections and use Trust model for skin tone detection. Then, we analyze how the distributions are skewed to a specific gender, skin tone, and attributes. With our social bias evaluation framework, we can now compare which models are more strongly skewed than others in terms of genders or skin tones. In our analysis, we found Mean DALL-E model is less biased than Carlo and Stable Diffusion in both gender and skin tone. We can take a look in which professions are biased towards specific gender for each model. Some professions are strongly skewed toward a specific gender by all 3 models. For example, we find all 3 models have strong tendency of generating male images for engineer. We hope our work to guide future progress in text-to-image generation models. We release our code and dataset. Thanks for listening.